Good afternoon, everyone. We are from Group 5. My name is Safyan bin Shaful Bahrain.
My name is Nazrin.
My name is Irfan Haikal.
And today, we will present an overview of our library management system project. So, the goal of this project is to develop a secure, efficient, and user-friendly system that streamlines library operations, such as book borrowing and returning. It also provides role-based access for admins and members. To achieve this, we use PHP for backend logic, SQL Server for database management, and HTML CSS for the front end. Our design is modular, separating presentation, logic, and database layers for scalability and security. So, in the task one, we prepared a proposal to design and implement the library management system. Our objectives are automate book management, borrowing, and returning processes, provide role-based access for admins and members, implement robust security measures like password hashing and SQL injection prevention. So, for the proposed hardware and software, so the system design has a three-layer structure. The presentation layer using HTML, CSS for the user interface, application logic using PHP for functionality, database layer with SQL Server for secure data storage. So for the database design, the users tracks users details like names, roles, and hash passwords. Books manages books inventory. Borrowing tracks borrowing everything of books. We also propose security measures such as parameterized queries to prevent SQL injection and role-based access control to restrict sensitive features. We'll pass it to Nazrin.
So I will be explaining the second part, which is the implementation of the application. So in this application, we have implemented the front end using HTML and CSS, and the back end is PHP for server-side logic, and database we use SSMS for storing user, book, borrowing records, and all the other records. So our system features the admin functionalities and also the member or the user functionalities. So the first thing that we implement is the user interface, which is this one. It is for the roles user. So for example, we can log in using a user. So I create a new account. And then log in. So this is the user's interface. And then the second part is the function for users interface, which they can borrow books from here. And then the second part is the admin interface. So we have already implemented the admin's role, admin user's role, which is this one. So we log in as admin. So this is the admin dashboard. Inside here, there's one of the functionalities, the security measurement, which is activity logs. We can see the logs of users that just logged in. For example, just now Nazrin and now admin. And also, we implement the security measures of hashing the passwords for all created accounts. Okay, and then the third one is the insert function, which is this one, the entry function. So just now I have created my user Nazrin. So in the database, it will update the data for user Nazrin, which is this one. And then if we delete this, So now we drop the account that I just created just now, and now I cannot log in. So the delete function is also working. Now we check here. So now Nazrin also is deleted from the database. Okay. So if we want to insert, we can just create an account every single time. So I think that's all for my part. Thank you. I will pass to Irfan next.
For trait modeling using strike and drag. We use strike to identify potential traits. Strike stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. For spoofing, it mitigated with authentication using hash password. For tampering, it prevent truth, prepare SQL statements, and input sanitization. For repudiation, activity log track all admin action for accountability. For information disclosure, enforce through HTTPS and encryption of sensitive data. For denial of service, it rate limiting can be implemented in the future. For elevation of privilege, the role-based access control ensure proper permission. For drag scoring, we rate the risk based on the drag model, where each risk is scored from 0 to 10. For damage potential, we rate it to 8 because the user data and system operation could be affected. For reproducibility, we rate it to 5 because it requires insider knowledge. For exploitability, we rate it to 4 because it's secure via input validation and authentication. For effective users, we rate it to 6 because secure via input validation and authentication. Eh, all users could be impacted. For discoverability, we rate it to 7 because vulnerability might be noticeable with patient problem. Next for PPDA. The Personal Data Protection Act 2010 protect the personal data of individual in Malaysia. It goes to safeguard personal information and ensure data is handled responsibility. It covers data collection, processing, storage, and sharing. For data collection, we collect only essential information such as username and hash password to minimize exposure. For data storage, sensitive data like password are stored securely using hashing technique. For data access, it role-based access control ensure only authorized personnel access sensitive data. For data retention, data is retained only as long as necessary for operational purpose. For penalty, for non-compliance, failure to comply with PDPA can result in penalties up to 500,000 Malaysia ringgit or imprisonment up to 3 years. By implementing secure authentication, encryption, and regular monitoring, we align with PDPA's principle to protect end users. That's all. Next, I will pass to Sophie.
Thank you, Irfan. So for task 5, the security measures implementation, in task 5, we implemented several security measures to protect the system from internal and external threats. I will show you some examples later, but for now, I'll explain what the security measures that we implemented. So for number one, we implemented authentication. We use PHP password hash to securely hash password during registration and password verify for login validations. This ensures passwords are never stored in plain text. For role-based access, the next one are role-based access control. These are admin functionalities like managing users and books. are restricted to authorized users. Regular members only can access member-specific features. For SQL injection prevention, we use parameterized queries to sanitize user inputs and prevent SQL injection attacks. And the next ones are session management. These implementation sessions are used to authenticate users and store critical information like username and role. A session timeout mechanism is implemented in connection.php to log out inactive users after 30 minutes. But after this, what I'll show you later, will show a lower timer. It will reduce the risk of session hijacking. So for the purpose of this, it prevents unauthorized access from the idle or stolen sessions. It secures sensitive information and stored in sessions. So for the next ones are the encryption of sensitive data. We implemented this so passwords are securely hashed using password hash. So for the purpose of this, it protects sensitive data. And the next one are regular backups. A PHP script, a backup database, is available to perform database backup. I will show you right now. If we run a backup database.php, it will show here a query that says backup created successfully in this file. And the next one is error handling and debugging. So for error and handling debugging, errors in database operations are gracefully handled using print R SQL library errors, that which is true during debugging. User-facing error messages do not reveal sensitive database details. It also prevents leakage of sensitive information, for example, database structure or connection details to end users. And for the second last is database access control. This database is accessed using a dedicated username and a password with limited privileges, as configured in connection.php. Administrative credentials are stored secretly and not exposed in the application code. Reduce the risk of privilege escalation or unauthorized access to the database. And the last one is testing for vulnerabilities. Basic SQL injection tests were conducted using parameterized queries to validate input centralization. And the purpose of it is to ensure the database is resistant to common threats. So, for example, now I will show you the activity. So let's now log out. So for example, I will log in as my ID, and then I will change the timeout. Right now is 30 minutes. I will change it to 10 seconds. Sorry, let's do it 5 seconds. Okay, so let's log in. It's too short, it's my bad. So let's put it for 10 seconds. Okay, so now we logged in, and then after 10 seconds, we will be logged out. Sorry. Okay. So as you can see here, your session has expired due to inactivity, and please log in again. That's all for our project. Thank you.
Thank you.